Hi guys, happy third day of e-learning. This is your e-learning lesson for Friday, February 4th. So a couple things I wanted to tell you guys. Those ClearSight corrections, a lot of you were still working on those at the end of class on Tuesday, which is totally fine. And on Canvas, it says they're due Friday, but we aren't in school. So instead, you need to bring them back to me on Monday. So you'll see that that's changed in the Canvas assignment, that they're due now on Monday, which is the next opportunity you have to bring them into me. The other thing is my plant. I got some good name suggestions, and there was a few that I really liked, so I sort of combined them all together. So here's what I decided would be the name of my plant. Michael Fred Sonny Scott. That's the name of my plant. Michael Fred Sonny Scott. So, Fred, just what a great name. Sonny, because he's in the sun. And then Michael Scott was an ode to one of my favorite shows. So, good names, guys. I liked them. Those were the top three I picked out, though. Michael Fred Sonny Scott. All one name. Very epic. All right, guys. So let's get into our lesson today. Today, you just have a video to watch. No homework. It's Friday, and we're going to keep the practice just to what's in our lesson. So should be just a quick time together, and then you guys can head out into the snow and build a snowbank or whatever you want to do out there. So here we go. Let me make myself smaller. You're going to grab those packets, expressions and equations, and you need to open in that packet past those card match pages and go to how do we simplify expressions, which should have those boxes at the top and look a lot like what I have here. All right, so we're still trying to make expressions as simple as we can, and we do that in math because we want to make things really efficient in mathematics. So one of the ways we do that is by using mathematical properties. So associative, commutative, and distributive. We've covered them a little bit before, but we're going to go into them even a little further in depth today. So the associative property, what this allows you to do is regroup. So let's write that out. You can regroup when you're adding or multiplying. So here's what that looks like. You could have something like 2 plus this group, 6 plus 10. An order of operations would tell you should do what's in parentheses first, but the associative property allows you to change how the numbers are grouped and you still get the same value. So you can rearrange it so that you actually do something like 2 plus 6 first. Sometimes this is really helpful based on what the numbers look like. So associative, I think of who do you associate with at school? Who do you group up with at school? Associative has those parentheses involved in it and moving parentheses around. Commutative sounds like the word commute, which people travel when they commute. And when you travel, you're moving around. The actual terms are moving around. So commutative allows us to rearrange the numbers. So you can rearrange terms when you're multiplying or dividing, or sorry, adding or multiplying, when you're adding or multiplying. So here's what that might look like. I'm kind of running out of room here, so it's hard to write on this little tablet. So I'm going to draw it up here, but you guys can just add it into your own notes. So let's say you had something like this, 1/3 times 4/5 times 3/2. So you could just multiply everything just like that, but the commutative property says you can move the numbers around in a way that's more helpful. So for me, I would actually start by multiplying these two things first, and then the 4/5 last, because I know that these threes are going to cancel. So it just makes things a little more efficient. So commutative has to do with numbers moving around and changing places. And then, of course, we just learn the distributive property again this week. So you can multiply a value into a quantity. So let's say that you have this. You have 2 times x plus 3. Well, the distributive property says that's the same value as 2x plus 2 times 3. Okay, careful thing. Some of you, when you're distributing, you are not distributing to all the terms, so you're getting things wrong. I noticed that on your guys' homework yesterday. So you maybe are making this mistake. You're writing just 2x, 2 times x plus 3. Let me show you this. That's not actually distributing correctly. If you're distributing correctly, the 2 is being multiplied by everything that's inside that quantity. So just a little note I noticed on some errors we're making with distribution. Okay, let's keep going down the page. So then we have a couple of phrases that we need to use, and that would be combining like terms. So we can combine terms with variables raised to the same power. So that's what we've been practicing the last 2 days, is using combining like terms. And then an equivalent expression is an expression that has the same value even though it looks different. So expressions with the same value even if they look different. Even if they look different. Okay, so just a quick example, that could be like 1/2 times x. That's equivalent to 2/4 x, right? Both of those have a value of 0.5x. Those are equivalent expressions. Same value, they just look a little different. Okay, so let's move on to these bottom tables to practice using our properties to simplify expressions as much as we can. So we're going to simplify each expression, and we're going to justify each step by using a mathematical property or one of those phrases like combining like terms or equivalent expressions. So you always want to start with distribution if you can. So always start with distribution. So check out this first problem. We need to distribute that -3 into both of those numbers. So when we do that, we have -3 times 4x. Well, that's -12x. And then we're adding -3 times 3. Don't forget to distribute to that. And then, of course, we just have this 5x at the end that we haven't done anything with. So what we used in order to get this new equivalent expression is distribution. That's how we changed it from the top step to this next step. Okay, so now I am going to rearrange this expression so that I can put things together that are similar. So when I look at this, I am going to actually put -12x and that +5x right next to each other. And I'm moving that -9 to the end. So I'm not changing how the numbers are grouped. I'm not distributing. I'm just moving the numbers around so that I have a more efficient problem. So I'm using the commutative property to do this, moving the numbers around. Okay, so now I am able to combine like terms in order to get everything simplified. So -12x plus 5x, I got -7x. And then that -9, no one to combine with. So we combined like terms in order to get this expression. And that's pretty much all we can do, right? -7x plus -9, that's just combining like terms. Some of you might have written it like this, -7x minus 9, and that's an example of an equivalent expression to the one right above it. Same value, just written a little bit different, right? Okay, so let's try this again. Always start with distribution if you can. And if you look at this problem, we can distribute that 2 into that quantity. So this first quantity, there's nothing to do with that right now, so let's just rewrite it down. We have 3x plus 6y minus 4 plus, now I need to distribute. 2 times x is 2x, And then we have minus 2 times 6, which is 12. So we use distribution to change the expression so far. Alrighty, so now this might seem a little unnecessary or extra to write, but I'm going to write down the next step because it's important to show why we can change the parentheses. Why can we combine everything that's written? Because right now, order of operations says we have to do everything that's in here, but we can't combine like terms until we're able to kind of add this 2x and minus 12 in as well. So we need to change how the numbers are grouped. And to change how numbers are grouped, we're changing how they associate. We're using the associative property. So I'm just going to put all of them in parentheses. So 3x plus 6y minus 4 plus 2x minus 12. I'm going to just put them all in a giant group together. And now I am able to rearrange some of my values so that I can get things that are alike close to each other, like 3x plus 2x. Those are both my x's. And then I see 6y's by himself. And then I've got negative 4 and negative 12. So what allows me to move numbers around is the commutative property. That's what allows numbers to commute, to travel, to move around, commutative. All right, so now I'm just going to use combining like terms to put together all the terms that have the same variable raised to the same power. So when we do that, we have 3x plus 2x, which is 5x, plus 6y. And then this very last bit, we have you treat it like negative 4 minus 12. So we have, I think we're starting at negative 4 on the number line, and so we're subtracting 12. So we're getting even further negative to negative 16. And that's as simplified as this problem can get. So when you're solving these kinds of problems, you're not going to end up writing all these justifications every time. But the goal is that you would internalize these rules that you can do these things, to know that you can make these changes with the numbers and you're not making any mathematical errors. So let's do one more on the next page where we need to actually write everything out, and then we're going to just assume that we know that we can use these properties to our advantage. So check out the next page. We're going to use a little bit of checking this time to ensure that we're doing everything right and to kind of prove that these properties do work. So by substituting a value for each variable, you can check that the expressions are equivalent. So when we start with this top expression, we should be able to check that it matches whatever we get down there by substituting in a value for the variables. So let's go through. We're going to simplify, and we're going to justify why we can do it, and then we're going to prove that we're right. So here we go. Here's our given expression. So we have this negative of the quantity 3x plus 2. We do have to distribute that negative 1, that negative in. So this is negative 3x plus negative 2. Remember when we learned about factoring, when we take out a negative, we flip the signs of the numbers. So we're going to flip those numbers back. All right, and now I've got this quantity 4x plus 2y minus 10. I can't just remove the parentheses yet. I've only used distribution so far, but what allows me to move my parentheses is the associative property. It allows me to change how the numbers are grouped. So we're going to use the associative property now to put all those numbers in a big group together so that we can operate on them in the way that we want to. All right, so we would have this expression. And now I'm going to use commutative property to move my numbers around how I want to. So I want to get things that are alike together. That way I can just combine them up. So I notice there's some things with x's. There's some constants that don't have any variables at all. And then there's this one with a y. Okay, so now I'm able to combine all the things that are alike. So I've got some x's and constants, and then this little y term all by himself. So let's combine everything, and we would have negative 3 plus 4 So that's a positive x. Negative 2 minus 10. That takes us to negative 12 on the number line. And then we just have this plus 2y right there. Okay, and so we use combining like terms as our very last step to get everything where we wanted. So in order to check our work, it said that we can substitute a value for each variable and show that we're right. So we want to make sure that this first expression here matches this bottom expression there. So let's choose some variable values and go from there. So let's let x equal 1 and we're going to let y equal 2. I like simple numbers, so I'm choosing 1 and 2. Okay, we're going to plug in these values into this very first expression. So we would have negative 3 times 1, because we're saying x is 1, okay, plus 2, plus the quantity, 4 times 1, 4 times x, but we're letting x be 1. We're substituting in, just like if you were playing soccer or football and you were changing positions, you were substituting in for someone else on the field. All right, let's keep going. So we have plus 2y. So we said let's let y equal 2. So that would be 2 times 2. And we're going to subtract 10 at the end. Okay, now we follow order of operations and start solving. So we would have negative 3 plus 2 plus, in here we'd have 4 plus 4 minus 10. So we'd have negative 5 plus 4 plus 4 is 8 minus 10. That's negative 2. Okay, so we have the opposite of 5 plus the opposite of 2. Negative 5 plus negative 2. This equals negative 7. So that's what we should get this bottom one to equal if we've done everything right. So let's check it. We have to use our same values for x and y, but this time we're going to plug it into this expression right there. So if x is 1, let me rewrite it here so you guys can see what's happening. We're going to put in 1 for x, and then we're still using 2 for y, so we're going to check and see where this takes us. 1 minus 12. You're starting at 1 on the number line, subtracting 12. This takes you to negative 11, and we're adding 4. So we're at negative 11, but we're moving in the positive direction. That does take us to negative 7. Look, both of these values are the same. They both check out. So we know that these right here are all equivalent expressions. So even though they all look different, they all have the same value when you choose a number for x and for y. Just different ways of writing things, right? This is like you when you're in your pajamas. This is you in your school clothes. This is you in your basketball uniform. This is you at the prom. And this is you in your choir concert. It's still you. You're just dressed up for different things. This is all the same value, just dressed up for different things. All right, guys, you're doing great. We're just going to finish out this page, and that's going to be the end of today. So 4 more problems, and that's it. I want you guys to do one with me, and then I want you to try the other ones on your own. So here we go. Number 1, the sum of negative 6n plus 3 and 4n minus 9. So it's not asking us to write the properties anymore. We're going to assume that you've internalized all these different things that you're allowed to do. So the sum of these two things, sum means addition. So we're being asked to add up these two quantities. So we're going to write it like this. This is the sum of these two quantities. So I'm going to go through. The associative property says that I can regroup these things how I want to. I don't have anything to distribute, so I'm good there. The commutative property says I can rearrange what I want to simplify. So I'm going to move my like terms closer to each other. And then we have negative 2n, when you have negative 6 plus 4, so that's negative 2. And then we have 3 minus 9. So you're starting at positive 3 and subtracting 9, you're going to end up at negative 6. So that is as simple as it can get. You cannot combine like terms any further. Go ahead and try the next ones on your own. Be careful on this one. You have to distribute this subtraction sign in. So let me get you started on it. We can leave this as 9 plus r. We are subtracting everything in this quantity. So when you distribute that negative 1 in, that is like subtracting r and also subtracting 10. Okay, try to work it from there on your own. Okay, you should get -1. Positive r and minus r, this is like having one r and taking away one r. So these guys end up canceling out and going to 0. So you end up with 9 minus 10 or -1. Okay, try number 3 and number 4 along with me. All right, here I'm going to use keep change change. Okay, so number 3, you should get -3v plus 6. You can check how I did my work. Some of you will get good enough at these properties that you don't need to even write out all of them, like the commutative property to move things around, but I'm showing those to you to show how everything works. So from here to here, I guess, sorry, I should back up one. From here to here, I use distribution to distribute my number. Then I was simplifying or using order of operations to solve some of the multiplication. So this is really just an equivalent expression. And same thing here. I just did keep change change to turn this into an expression that I like working with better. And then here I use the commutative property to rearrange it. And then this last little bit is just combining like terms. So that's how I did everything for that problem. All right, so go ahead and work number 4, and that'll be our last problem for this Friday. This one I think is actually even one of the easier ones on the page, but it just goes to show that you're adding these two things. You need to use the associative property to change how they're grouped. That allows you to then combine like terms to be able to simplify. So you have a -4 and a +3. Your result is -1y. So some of you might be wondering if you can write it like this. That would be okay. That's an equivalent expression to this. That's good. That works. Or some of you might have it written like this, 8 minus y. That's an equivalent expression. All those things are equal to each other. So those all work. They all have a simplified value that you can't combine like terms on any further. All right, guys, we are going to practice all of this in class on Monday even more. So you don't have any homework. You don't need to do any practice for this set here. This was enough for today. Remember to do those clear sight problems this weekend to increase your score, and I hope you guys have a great weekend outside, inside. Stay warm, stay healthy, and I'll see you guys on Monday.